Okay, let's dive into this one. We're going to tackle a massive 16-mark question on crude oil from a real AQA GCSE chemistry paper. Our mission? It's simple, to show you exactly how to lock in every single one of those marks. And here's the secret weapon. We're going straight to the source, the official AQA mark scheme. This way, there's no guesswork. We'll see exactly what the examiners are looking for, right down to the specific keywords and even the alternative answers that'll still get you the points. So, that's the big question, right? How do we actually secure all 16 of those marks? This single question covers a whole lot of ground, but don't worry, we're going to break it down piece by piece. Let's jump right in. All right, first up is question 4.1. This is a big one, a 4-marker right at the start. You know, if we can nail this, it gives us a huge confidence boost for the rest of the question. And it's all about that fundamental process, fractional distillation. So, the question is asking us to explain how we get these specific fractions, lubricating oil, naphtha, and petroleum gases, from crude oil. And notice it's worth 4 marks. That's a big clue that the examiners want 4 clear, logical points in your answer. Okay, so here's exactly how you get those 4 marks, step by step, straight from the mark scheme. Mark number 1, you've got to say that the crude oil is heated to vaporize the hydrocarbons. For your second mark, you need to mention the temperature gradient in the column. You know, how it's super hot at the bottom and gets cooler as you go up. The third mark comes from explaining that the hot gases rise, cool down, and condense back into liquids at different levels. And finally, the fourth and most crucial point, why does this happen? It's because the different fractions have different boiling points. Get those 4 points down, and you've got the marks. Okay, we've got fractional distillation down. Now, the questions are going to shift gears a little bit, focusing on the products we make from crude oil and, well, the pollution they can sometimes cause. So, question 4.2. This is a pretty straightforward 2-marker asking you to pick out 2 useful materials made from petrochemical feedstock. And if we look at what the examiners want, the 2 correct answers are detergents and solvents. Simple as that. 1 mark for each. Easy peasy. Next up, we've got a real classic chemistry skill, balancing a combustion equation. You're given the hydrocarbon C9H20, and you have to write out the full, balanced equation for its complete combustion. All right, let's walk through this balancing act. To get the full 2 marks, it has to be perfect. So first things first, the carbons. We have 9 on the left, so we need 9 CO2 on the right. Simple. Next, hydrogens. We have 20 on the left, so we need 10 H2O on the right to make 20. Now for the slightly tricky bit, the oxygens. On the right, we've got 18 from the CO2 plus 10 from the H2O, which is 28 oxygens total. So on the left, we need 14 O2. But hey, check this out. This is a great little tip from the mark scheme. Even if you mess up the balancing, you can still get 1 mark just for knowing that the products are CO2 and H2O. That's a really useful safety net. Okay, now we're moving on to an environmental question. For 2 marks, you need to explain why having sulfur impurities in petrol is such a bad thing. So to get your first mark, you've got to identify the nasty pollutant that's formed. When sulfur burns in an engine, it reacts with oxygen and produces sulfur dioxide. Just naming that chemical gets you your first mark. And for that second mark, you just need to explain what that pollutant does. The mark scheme is pretty cool here. It gives you a couple of options. You can either say that sulfur dioxide causes acid rain, or you can say it causes respiratory problems. Either answer is perfect for that second mark. All right, moving on. This next section really dives into the nitty-gritty of the hydrocarbons themselves, looking at their physical properties and how we can actually change them. Here's a classic 2-mark question. It's asking you to justify why heavy fuel oil is more viscous, thicker and gooier than kerosene. You've got to connect the dots between different properties. So the whole key here is to connect the size of the molecule to how viscous it is. For the first mark, you need to state that heavy fuel oil has larger molecules than kerosene. That's your first point. For the second mark, you connect it to the property by saying that these larger molecules have stronger forces between them, which makes the liquid more viscous. The mark scheme also says you can argue it the other way around for kerosene, which is good to know. Okay, here we go. A 3-marker. First, you need to name the process for chopping up big hydrocarbons into smaller ones. And then you've got to give the 2 conditions needed for it to happen. Right, mark number 1 is just for naming the process. And this is a pure memory recall question. The process is called cracking. It's where we take those large, not so useful hydrocarbon molecules and break them down into smaller, much more valuable ones, like petrol. Now, for the other 2 marks, you need the conditions. For the first one, you just have to say high temperature. And the mark scheme is really helpful here. It even says you can state a specific temperature, anywhere from 300 to 900 degrees Celsius. For the final mark, you need the second condition, and you can either write steam or catalyst. Either one will get you the point. All right, let's wrap this up with the final part of this big question. It's a 1-mark multiple-choice problem that's all about testing if you can spot the difference between different types of hydrocarbons. So the question is asking which of these pairs would both turn bromine water colorless. Remember, this is the classic chemical test for an alkene, a molecule with a carbon-carbon double bond. So all we need to do is find the option where both molecules are alkenes. And the correct answer is D. Why? Well, because both of these are alkenes. They fit that general formula for alkenes, which is CnH2n. See how C7H14 is 7 and 2 times 7, and C8H16 is 8 and 2 times 8? The other options all have at least one alkane in them, and alkenes won't react with bromine water. Phew, okay, so we've just worked our way through all 16 marks. So what are the big takeaways here? What have we really learned from breaking this whole thing down? I mean, just think about the range of stuff we've covered, right? We had a big industrial process, the link between molecular properties and things we can see, recalling names and conditions, balancing equations, environmental chemistry, and identifying hydrocarbons. The big takeaway is that these huge questions aren't just about one thing. They are designed to test how you connect lots of different ideas together. Mastering that is the real key. And just like that, that's how you can bag all 16 marks. So I'll leave you with this thought. Now that you've seen exactly how the marks are given out, which one of these areas would you go back and revise first? Figuring that out is the best way to get ready for your exams. Thanks for joining me.